So water, we're around it all the time. It does some really weird things that we're actually not, we don't really think about. They do these things called adhesion and cohesion, and they do some really weird things that other molecules don't do. But because we're around it so much, we sort of take it for granted. So cohesion means molecules stick together. And it makes sense. If you remember those hydrogen bonds, they're kind of like little magnets. So if you ever see two drops of water sitting near each other, they eventually sort of bind together and sort of come together. That is a process called cohesion. And adhesion is molecules stick to other stuff. So adhesion would be like the water molecules sticking to the side of your glass, or the water molecules sticking to something else. The table or plastic cup or something. And that's just because it's adding itself to another thing. And again, it's those same exact charges that make it stick to it. So these are both based off of those positive and negative charges, adhesion and cohesion. And an example of this is a glass of water. Cohesion is where water sticks to other water, and adhesion is where water sticks to glass. And if you ever pour water on like a flat surface, what you'll see is that it'll slowly come together and bind. Water also has this thing called surface tension. And surface tension is basically how it's difficult to break the surface of the liquid. That tension is because they all bond together and form a thin, almost a hydrogen bond, like a thin film. And that's why bugs can walk across it and they don't fall through. If you ever have bugs in your house, what I like to do is I break that surface tension of water. They're so used to walking on water and not falling through that what I do is I add just a drop or two of soap to water. And what will happen is when the bug lands on it to take a drink or to do whatever it needs to do, there is no surface tension because the soap actually breaks it. So now what happens is the bug actually sinks to the bottom and dies and drowns. But because of that surface tension, normally it will be able to just sit there and do whatever it needs to do. Water does a lot of other stuff. So for instance, when you heat water, the amount of energy that goes into it starts to make that stuff move around rapidly. So temperature is a way to measure heat, and the average speed of molecules is what we're kind of looking at. So the higher heat, the higher the molecules move, and the higher the temperature. So water helps temperature resist heat. So it takes a lot of energy to make water go up a degree or so, and we can actually measure that. And the way we measure calories with food is basically we burn it and see how much that water increases in temperature. And that we can kind of extrapolate with how much energy is in that food. So for instance, let's say something like a Twinkie that has a lot of sugar in it. If we burn it, it catches on fire and it stays on fire for a while. And it's the sugar that's actually burning up. If you take something that's like a bran cookie or something and burn it, because there's not a lot of sugar in it, it's actually going to not raise the temperature of water that high, and we know that that has lower calories than something like, like that Twinkie. So basically what happens is it has a tolerance not to increase in temperature unless it's hit with a lot of heat, and we can measure that. So what you're seeing is over here, you're seeing what water would look like in a normal glass. So this is just room temperature water. These molecules are bouncing around. But if you throw them in the freezer, what happens is because they don't have that ability to bounce around and move, they have to get to a comfortable area and distance away from each other. So they form these sort of rings. And you've probably noticed it. If you've ever taken a water bottle and filled it with water and then froze it, what you found is the water bottle poofs up. And it's poofed up not because somebody added water and put it back in. It's poofed up because before these guys were tight and compact and they could bounce on each other. But as you froze them, they organize themselves in this manner, and that pushes on the plastic, and that's what makes them sort of poof up. Of course, when you let it go back down to room temperature, they return to something like this. When we do heat up water, what happens is these guys bounce around so much that they can actually bounce out and sort of literally start to come out of the solution if this was boiling water. And that's what we call steam. These guys are bouncing around so much and flinging around so much that you'll actually see them come up as steam. The next thing I kind of wanted to talk about is what water does for us and how we use it. Water is what we call the solvent of life. And when we think about solvents, we think about these things called a solute and a solvent to become a solution. A solute is what gets dissolved in a liquid. A solvent is what's doing the dissolving. So in my first example, here's one of those energy drinks. They usually have a bunch of electrolytes in it, which are a bunch of different types of salts and other things. So the solute would be the salt. The solvent, what's the salt getting dissolved in, would be usually water and a bunch of other things. And then together, when they're mixed, is going to be the solution. So for instance, if I were to make a cup of tea, what would happen is, or coffee, that's easier to think about, the water would be the solvent, the coffee would be the solute, and when they come together, they would be a solution. Or if I had coffee and I mixed sugar in it, the solute would be the sugar, the coffee would be the solvent, and when I mixed it together, it would be delicious. It would be the solution. But we know that water doesn't like everything, and it repels some stuff. And hydro means water, so hydro means water, philic means love. So there's a lot of things water loves, so you could put water and salt together, you could put water and vinegar together, they mix together really, really well. Hydro in Greek means water, phila means loving, and these are polar molecules that come together and they stick together because they have similar charges. The other thing that we deal with in biology and even in our bodies are things that are hydrophobic. Phobic means fear. So something that's afraid of something. So if you've ever looked at oil and vinegar in something like dressing, you have to shake it up really hard to get it to distribute out. And that's because water hates oil. So hydrophobic. So the oil is fearing the water and doesn't want to dissolve in. And that's because these things are non-polar. And because there's no pole to them, they just separate out. If there was a positive-negative charge, they would dilute really well together, and they'd be hydrophilic. But if they were polar, they don't, and they sort of separate out. And that's why oil and vinegar needs a little shaking. We'll talk a little more about hydrophilic and hydrophobic items when we talk about the inner workings of the cell. Well, also, if you take Bio 201 and 202, when we talk about hormones, we're going to talk about some that are hydrophilic and love water, so they mix really well with blood, and then some, like steroids, that are hydrophobic, and they hate water, so you have to do special things to them to get them from point A to point B in your body just to move them to those specific cells to get there. And we'll talk more about that in Anatomy number 2, if you take that